All right, I'm going to give you an update on the JKI Security Suite. Last year, I talked a little bit about JCrawler, JKI's LabVIEW static analysis tool. In the last year, it's grown a lot, and now we kind of have a suite of tools that I'm really excited to tell you about. Now, those of you who've heard me talk before, you've heard me talk a lot about our NASA and Department of Defense projects that JKI has worked on, where we have a lot of assurance, a lot of paperwork, a lot of deliverables, that we have to turn in. Now, I do want to thank Jorg for perfectly setting up my presentation, because I'm only going to talk about the LabVIEW part of security. I'm not going to talk about door security. So who needs security? Who here writes code for NASA or Department of Defense? All right, a surprising number of you. Now, if you don't write code for that, you may write code for a transportation or aerospace application or electric vehicles that can really hurt people. You may be working with poisonous or hazardous chemicals. You may be working with biomedical devices. There's obviously some important things and trust there. You may just be working with really expensive products that you're testing or on production lines that need to be up 24/7, or 1,000 other reasons that I can think of why it's really critical that someone can trust your code. What are you doing to earn that trust? Other than coming to GDevCon and learning best practices from your peers, what are the things that you can do to make your code trustworthy? I think there's three kind of main parts that we can think of. We want our code to be high quality, we want it to have good security practices, and we may need some assurance paperwork. We may need to turn in some documents. So for quality, we need to start by having standards that we can map to, written standards. We need to have training materials so we can train our users. We need ways to validate that that's being used, and ideally ways to automate that so we can scale. For security, we need LabVIEW specific guidelines. Ideally, we want to cite some of those industry standard security practices. We want to be able to scan things automatically and triage them as they happen. We need a documented process that we follow, specific to software, but also if you're trying to pursue one of these like ISO certifications, a lot of other things. In the end, the thing that we often need to create is signable prose. You may have to make an attestation that you followed all NIST requirements, and that's just some words that you wrote that are legally binding. And so how do we do that? So what's driving this surge in security is a lot of these international standards. You heard Jorg talk about the CRA. My favorite requirement for the CRA is that all software must be shipped free of vulnerabilities. Yeah, starting in December of 2027, no more bugs. So cool. So if you're trying to map to these standards, it can be difficult. And the standards are written to be frustratingly vague. So here's an example. CWE, so CWEs are the periodic table of security vulnerabilities. They're written in language agnostic computer science terms. So there's a way you can take advantage of some programs by injecting a string that is then interpreted by that computer in a way that's hazardous. And so you may have seen some of these examples where someone puts drop table in the license plate camera, takes a picture, and then deletes its whole database. So what are the places in LabVIEW where we can do that? So what we did at JKI was we created our JKI Cybersecurity SDP, Software Development Plan. This is LabVIEW-specific development standards, details on configuration management, topic-specific cybersecurity checklists, guidelines on creating a wide set of deliverables, and if you happen to need to apply this retroactively to an existing code base because you're not starting from scratch, a guide on how to apply it. We call it heritage code, not legacy code. It's heritage. We also do have a NASA version that's specific to NASA's NPR 7150 for those who need it. So the SDP is kind of one half of our equation. The other half is JCrawler. JCrawler is a LabVIEW static analysis tool. Similar to VI Analyzer, but it has a lot of specific capabilities. We can run it from LabVIEW, we can run it through the GCLI, we can run it through PowerShell and incorporate it into our CI/CD pipelines. It's going to produce a console output, a CSV report, and new for the most recent version of JCrawler, it's now storing all of its data in a database. This is going to go and check every single file in your repo, LabVIEW or not just VIs like VI Analyzer, it's also checking controls and classes and LVLibs to make sure that everything's okay. It's going to check and make sure nothing's broken, that you've separated compiled code, that you've turned off automatic error handling, all those things I talked about for some of the code I write. But we've also just released our first set of security-specific tests. So last year I talked about the OS command injection and CWE 78, and I said, sure, wouldn't it be great if you could go through your code and find everywhere where you've called a system exec and make sure that you didn't wire a string control into it? Now we do that with JCrawler. So now with JCrawler, we can go and identify every single sysexec and see if you have string constants wired into it. And of course, we're doing this through scripting. And so JCrawler under the hood is using a lot of different scripting. Right now, the first iteration is just saying, is it a string constant? If it is, it's safe. And this includes both for OS command as well as for the DLL. If you are using a control, that you're going to get a warning. And I don't recommend that you write a sub-VI that passes a raw string straight into a sysexec, because someone can say delete C drive and see what happens. Now, another one is deadlock. One of the CWEs, CWE 833, talks a lot about deadlock, of where in your code can you accidentally get stuck waiting forever. Here's a list of functions that have a default -1 timeout. So I want to be able to go and find all of those in my code and make sure I'm not locked. We've also just released the JCrawler Explorer. So now that database that JCrawler creates, we can load that up in a React-based web tool that allows you to go then browse, triage, find your warnings. So that's JKI Security Suite, the SDP plus the static analysis tool that's all dialed in specifically to LabVIEW to help you meet some of these cybersecurity technical requirements. In the end, I think we check every one of these boxes. I'm going to make Jeff go all the way because I know he's only happy when he gets to yell. So we are in early access for JKI Security Suite. It's not completely done now. We have a great set of tests already. If you'd like to join us, please let me know and grab a business card. I'm also going to be releasing a newsletter article on the top 25 CWEs that are LabVIEW specific. So if you want to get that article, we'll publish that and send it out in our newsletter. Thank you very much. I'm going to keep talking.